So we will be working with Zodiac Aerospace. We currently have multiple locations in Southern California, but we will specifically be analyzing the facility in La Palma. And they specialize in designing and manufacturing airline cabin interiors, so cabin interiors such as galleys, lavatories, storage compartments, and seating monuments. And in this facility, they produce at a high variability, low volume rate, and the automation in this facility is limited. They only have a CNC machine, and they put the emphasis on their labor with technicians and workers. And the current problems that this facility faces are long curing process times for the adhesives. There's elongated travel paths, and there's also issues with line balancing. And our overall project objective is to address these issues that I've just stated and ultimately increase the production rate, increase the efficiency, and at the same time eliminate the non-value added tasks. And that will all contribute towards lowering the production costs.
So for the scope of our project, we'll be putting our scope focus into the La Palma facility alone. And this is because raw materials such as filler materials and fiberglass sheets are easily stored within the facility and leaves less room for logistics issues with outside of the facility. And there are multiple departments within the facility, but we will be putting our emphasis on the manufacturing floor. And also within the manufacturing floor, there are certain families of items, such as the lavatory shown above over here, which causes high stress in the operation, and we'll be looking deeper into that. And also, we'll be going into the following phases for our project: investigation, data collection, analysis, design, and validation. And we'll be looking deeper into these phases in the next slide.
Our group's plan of attack first starts with investigating the facilities and understanding its processes. We want to become more familiar with the different departments within the facility and the overall movement and flow within it. Then we want to acquire data, the data collection phase. And with that data, we're going to organize it and analyze it so that it's a lot easier to understand. Once we graph that, we can design and validate it. And we can do that through different checks, through resources and professionals. And the implementation of our project is the final step, and that can be done if we are given the right time frame and if the company allows us to implement or if they decide to implement.
So here are just a few of the relevant courses that we have listed. For example, we plan to use IE 392 in its lean methodology in the manufacturing floor. We have IE 417 and 429 for its theory on queuing as well as discrete simulations, and IME 403 for its engineered cost estimating. However, these are just a few of the many. As we enter the data collection phase and analysis phase, which we will later see on in the Gantt chart, some other problems might arise, some other opportunities might arise that we will use the tool sets and skills from those classes and appropriately apply them. So here we have just a simple Gantt chart with a few of the important due dates. As you can see, we're beginning very slow and steadily, just about finishing the third week with the senior project proposal. However, next week things should start to pick up pace as we enter the data collection phase, where we have a good amount of time. And we also, the Gantt chart goes all the way until EGR 482, which is next quarter. So hopefully we'll still stay on track by then. Do you have any questions?
When you have high variability and low volume, you have the perfect condition for implementing group technology. I didn't see anything on that. Cellular manufacturing. And then within the cells, you're talking about line balancing. So make a note of those. I didn't see MFE 450 and 476, or IME 450 and MFE 476.